Hotep, and welcome back to African Metaphysical Center for Spiritual Healing, Mind, Body, and Spirit Development. I'm your host, Dr. Daryl Greer, your metaphysical practitioner, Reiki master, and Qigong instructor. Today is probably going to be one of the longest videos that I do because of the topic itself, time and space. So this is episode 2 on this 5-part series, Time and Space. In this second of 5 episodes, we dive into the dimensions of time and space. We explore the theories of relativity, quantum physics, and the concept of space-time. We discuss how these dimensions intertwine and influence our understanding of existence. From the bending of time to the vast expanse of the universe, we contemplate the mysteries that lie within these dimensions. Special theory of relativity. This theory deals with the behavior of objects moving at high speeds. It states that the laws of physics are the same for all observers in uniform motion relative to each other. One of the key ideas is that the speed of light is constant for all observers, regardless of their relative motion. This theory also introduced the concept of time dilation, which means that time can pass differently for different observers depending on their relative motion. General theory of relativity. This theory describes the force of gravity as a result of the curvature of space-time caused by massive objects. In other words, it explains how gravity works as a distortion of the fabric of space-time. It also predicts phenomena such as gravitational time dilation, where time runs slower in stronger gravitational fields. Quantum physics is the branch of physics that deals with the behavior of matter, and energy on the smallest scale. It was developed to understand the behavior of particles such as electrons and photons. Quantum mechanics. This is the foundation of quantum physics. It describes the behavior of particles in terms of probabilities and wave-particle duality. It suggests that particles can exist in multiple states simultaneously until observed or measured. The uncertainty principle, one of the fundamental principles of quantum physics, is the Heisenberg uncertainty principle. It states that there is a limit to how precisely certain pairs of physical properties such as position and momentum can be known simultaneously. The concept of space-time combines the 3 dimensions of space with the dimension of time into a 4-dimensional framework. According to Einstein's theory of relativity, space-time is not a fixed and absolute background, but rather a dynamic fabric that can be affected by mass and energy. It provides a uniform framework to describe the motion of objects and the effects of gravity. It also introduces the concept of the speed of light as an ultimate cosmic speed limit. On the other hand, the general theory of relativity explains how gravity warps space and time, giving rise to the phenomenon of gravitational time dilation and gravitational waves. Quantum physics not only expands our understanding of the fundamental building blocks of the universe, but also poses intriguing questions about the interplay between time, space, and consciousness. The concept of space refers to the 3-dimensional areas in which objects and events exist and move. It includes everything around us, from the vastness of the universe to the immediate environment we perceive. Space provides a framework for understanding the position, distance, and size of objects relative to one another. Time, on the other hand, is the measurement of the sequence of events and the duration between them. It allows us to perceive the order of events and their relationships to one another. In physics, space and time are interconnected and form a four-dimensional framework called space-time. This concept arises from the theory of relativity, which suggests that space and time are not separate entities, but are woven together, influencing how objects behave and how events unfold. The dimensions of time and space play a crucial role in shaping our perception of existence. Time provides the framework for the unfolding of events and allows us to perceive change and motion. It gives us a sense of past, present, and future, helping us make sense of the world around us. Space, on the other hand, provides the context in which objects and events occur. It allows us to perceive distance, size, and spatial relationship. Our perception of space enables us to navigate our surroundings and understand the spatial arrangements of objects. Together, time and space create a multidimensional framework that shapes our perception of reality. They influence our understanding of cause and effect, the continuity of experiences, and our sense of self within the world. Moreover, our perception of existence is influenced by the limitations of our sensory perception. Our senses provide us with information about the world, but they are not all encompassing. For example, our vision is limited to a certain range of wavelengths, and our hearing is limited to a specific range of frequencies. These limitations shape our perception of reality and may prevent us from perceiving certain aspects of existence. The dimensions of time and space, along with the limitations of our sensory perception, significantly shape our perception of existence by providing a framework for understanding the unfolding events and the spatial arrangements of objects. Our understanding of dimensions plays a significant role in fields such as cosmology, astrophysics, and even our daily lives. Dimensions refer to the number of coordinates required to describe the position of an object in space. In our everyday experience, we are familiar with three spatial dimensions: length, width, and height. In cosmology and astrophysics, the concept of dimensions is crucial for understanding the structure and behavior of the universe. For instance, the study of higher dimensions, such as the fourth dimensions, is important in theories like string theory and M theory, which aim to explain the fundamental forces and particulars in the universe. These theories suggest that there may be additional dimensions beyond the three we perceive, which could have profound implications for understanding the nature of reality. In our daily lives, dimensions impact the way we interact with the world. For example, our perception of space and distance is based on the three dimensions of length, width, and height, right? Our understanding of dimensions also influences technology we use, such as GPS navigation systems that rely on three-dimensional coordination to provide accurate directions, right? Furthermore, dimensions can influence our perspective on reality and our place in the universe. Exploring the concept of higher dimensions can expand our imagination and challenge our preconceived notions about the nature of the world we live in. It encourages us to think beyond what is immediately observable and opens up possibilities for new discoveries and innovation. Overall, our understanding of dimensions has far-reaching implications in various scientific disciplines and can shape our perceptions of the universe and our daily experience. Now, let us explore the intriguing phenomenon of time dilation, which occurs in extreme circumstances such as near black holes or at high speeds. Time dilation is a fascinating concept in physics that occurs when time appears to pass differently for different observers. It is a consequence of the theory of relativity posed by Albert Einstein. In simple terms, time dilation suggests that time can be experienced at different rates depending on factors such as relative motion or gravity. This means that time can move slower or faster for different observers, leading to a preconceived difference in the passage of time. One example of time dilation is the famous twin paradox. Imagine two twins, one staying on Earth and the other traveling into space at a significant fraction of the speed of light. When the traveling twin returns to Earth after a while, they would have experienced less time compared to their twin who remained on Earth. This is because the high-speed motion of the traveling twin causes time to slow down for them relative to the stationary twin. Another example occurs near mass objects like black holes. The intense and gravitational field around a black hole causes time to slow down for an observer near it compared to someone farther away. This means that time would appear to pass slower for someone close to the black hole than for someone farther away. These examples demonstrate that time dilation is not just a theoretical concept, but it has been experimentally confirmed through various experiments and observations. It is a profound and intriguing phenomenon that challenges our intuitive understanding of time and shows us how our perception of time is influenced by motion and gravity. In conclusion, as we conclude our journey through the dimensions of time and space, we acknowledge the profound mysteries that exist within them. From the abstract theories of relativity and quantum physics to the practical implications on our understanding of existence, these dimensions continue to captivate and challenge our minds. Join us in the future episodes as we unravel more secrets and mysteries that lie in the heart of our fascinating universe. Thank you for listening to Time and Space, and until next time, Ashe, Ashe, Ashe.